Hey everyone, welcome back to another lesson in MCV4U. Today we'll be looking at intersections of lines in R squared and R cubed, again, or in 2 space and 3 space. So here, again, if we have two lines in, again, 2 space, then the lines may be parallel and distinct, which means that there is no point of intersection. Parallel and coincident, which means that there is an infinite number of points of intersection, or non-parallel, which means that there would be exactly one point of intersection. So here, if we look at example number 1, it says, find the point of intersections, if any, for the two lines given below. So here, line 1 is given as x is equal to -3 plus 4t. And then we have y is equal to 5 minus t. And t is here an element of real numbers. And line 2 is we have x minus 13 over 2, which is equal to y plus 14 over 7. Here we'll write it in our parametric form for line number 2. So here we get x is equal to 13 plus s, and y is equal to -14 plus 7s. And so here, if line 1 intersects with line 2, what we'll see is that we will have the same. So here, if we label these, we'll label these x1, y1, and we'll label for line 2, x2, and y2. And here what we'll do is we will set x1 equal to x2, and we'll set y1 equal to y2. So here we have -3 plus 4t. x1 is equal to 13 plus 2s, which is x2. And for y1, we have 5 minus t is equal to -14 plus 7s. Here, we want to make one of our coefficients for our variables the same. And so here we're going to multiply this by 4 to get it to -4t. Here, if we rewrite this, we get we get 20 minus 4t is equal to -56 plus 28s. And then we rewrite our other equation, which was -3 minus, or sorry, -3 plus 4t is equal to 13 plus 2s. Here we see that, again, -4t and +4t, if we add these two equations together, those will cancel out. And here we'll get 17 is equal to -43 plus 30s. Here, if we add +43 to both sides, we get 60 is equal to 30s. And therefore, we get s is equal to 2. Here, once we get s is equal to 2, we'll sub that back into one of our equations. And so here we have 5 minus t is equal to negative 14 plus 7 times 2. 5 minus t is equal to 0, and therefore t is equal to 5. So to find the point of intersection, what we'll do is so to find, again, the POI by substituting s or t in their respective equations. So here we get x1 is equal to negative 3 plus 4 times 5 is equal to 17 here. And so for y1, we get 5 minus 5, which is equal to 0. And so here the point of intersection would be 17 and 0. But again, we can check it by substituting it into x2 and y2. Here, x2 then is equal to 13 plus 2 times 2, which is equal to 17. And y2 is equal to negative 14 plus 7 times 2, which is equal to 0. So we see that that confirms, again, our point of intersection here is at 17 and 0. Here, if we have two lines in 3 space or R cubed, then the lines may be, again, parallel and distinct. There is no point of intersection if it's parallel and distinct. Parallel and coincident, which means that there are infinite points of intersection, and then every point on the line is a solution. Non-parallel and intersecting, and there's exactly one point of intersection. And then finally, if it's non-parallel and not intersecting, there are no points of intersections, and these lines are called skew lines. The skew lines are here in lines which are not parallel, but do not intersect since they lie in different planes in 3 space. So here it says find the point or points of intersection, if any, for line 1. And here we have our vector r is equal to 13, 5, and negative 7, plus k, 8, 2, and negative 6. And for line 2, we have x plus 3 over negative 4 is equal to y minus 1 over negative 1 is equal to z minus 5 over 3. So here, if we rewrite these equations, we'll get vector m1 is equal to 8, 2, and negative 6. And so if we divide that by 2, that'll be equal to 4, 1, and negative 3. And here, if we rewrite our value in line 2, we get m2 is equal to negative 4, negative 1, and 3. If we divide this by negative 1, we'll get 4, with 4, 1, and -3. So here we see that line 1 is collinear to line 2. And so what we'll do now is we will verify if point from line 2 is on line 1. So here the point then from line 2 will be -3, 1, and 5. So here we have point -3, 1, and 5. And so here line 1 is x is equal to 13 plus 8k, y is equal to 5 plus 2k, and z is equal to -7 minus 6k. So here if we sub in our values, we'll get -3 is equal to 13 plus 8k, k is equal to -2. For y, we sub in 1, 1 is equal to 5 plus 2k, and then here k is equal to -2. And then for z, we get 5 is equal to -7 minus 6k, and k is equal to -2. So here what we see is therefore -3, 1, and 5 is on line 1, which proves again that they are coincident lines. Okay. And so that means that they are parallel and coincident, which shows that, again, there is infinite points of intersection. Okay, so example number 3 here says find the points of intersection, if any, for line 1, which is x, y, and z, is equal to 5, -2, -9, and 2, plus t, 1, 4, and -2. And here t is the element of real numbers. Line 2 is, again, here x, y, and z is equal to 1, 8, and 0, plus k, -2, 3, and -1. Okay, and here what we notice is we see that here are direction vectors 1, 4, -2, and -2, 3, and -1 are not collinear. So here we'll just write a note. So direction vectors are not collinear. Okay. And so here we'll write our equations. Again, here we have x1 is equal to 5 plus t, y1 is equal to -9 plus 4t, and we have z1 is equal to 2 minus 2t. Here, those are equal to x2, which is equal to 1 minus 2k, y2, which is equal to 8 plus 3k, and Z3, which is equal, or sorry, Z2, which is equal to 0 minus 1k. Now here, we again only need these two equations. So here we only need two equations. Equations. Solve for t and k. We need to double check the third equation. Okay, so here we have 5 plus t is equal to 1 minus 2k. And we have our second equation, which is negative 9 plus 4t is equal to 8 plus 3k. Here we're going to take our first equation and I'll multiply that by 4. So here if we write that, we get 20 plus 4t is equal to 4 minus 8k. And here we will subtract our two equations. And these will cancel out, our 4t and 4t, which leaves us with negative 29. 0 is equal to 4 plus 11k. So negative 33 is equal to 11k, and therefore k is equal to negative 3. So here we have k is equal to negative 3. Step that back in for our equation to solve for t. We have 5 plus t is equal to 1 minus 2 times negative 3. T is equal to negative 5 plus 1 plus 6. And so here we get t is equal to 2. So here we'll use our third equation to again check. So here we get Z1 is equal to 2 minus 2 times 2, which is equal to negative 2. And Z2 is equal to negative 3, which is equal to 3. And so here we see that the answers are different or not the same, which means that therefore no point of intersection, skew lines. Okay, and example 4 here again says to find the point or point of intersection where the line below crosses the coordinate axis. And so here we have x is equal to negative 9 minus 3t. Y is equal to negative 2 minus 2t. And z is equal to 15 plus 5t. And here t is an element of real numbers. Okay, so the first thing we'll look at here is again the point of the x-axis, and then we'll repeat that for the z and y-axis. So here, first thing here, point of intersection with x-axis, point of intersection with x-axis, which means that the point will be x, 0, and 0. So what we'll do here is we'll set the y and z equations to equal 0. t values are the same. The t values are the same, and the line crosses the x-axis. So here, if we make again y and z equal to 0, we'll get here 0 is equal to -2 minus 2t. And so therefore 2 is equal to -2t, and t is equal to -1. For z, we have 0 is equal to 15 plus 5t. -15 is equal to 5t, and therefore here t is equal to -3. And so here these are not the same. Okay, we're going to repeat the same thing for the z, y, and z axis. So here, the second one, we'll look at a point of intersection with the y-axis. So that point would be 0, y, and 0. So here again, we will sub in the values of 0 for the x and the z equation here. So here we get 0 is equal to -9 minus 3t. And so here we get t is equal to -3. And we get 0 is equal to 15 plus 5t. And here that's equal to -3. And so here we see that there is, again, the same. And then we have to find our POI. So we will sub in -3 back into our y equation. So y is equal to -2 minus 2 times -3, which will equal to 4. So here our point of intersection with the y-axis is 0, 4, and 0. And then lastly, the point of intersection with the z-axis. Point of intersection with the z-axis here, and that would be 0, 0, and z. So here we'll sub in 0 for the x and the y-axis. So we have 0 is equal to -9 minus 3t. Here t is equal to -3, as we found before. And then same thing here for y. Again, we had 0 is equal to -2 minus 2t, and t is equal to -1, which these two we already found before, but again, just to check, again, here they are not the same. And so, again, therefore, there's no point of intersection with the z-axis. Okay, so the only point of intersection lies with the y-axis at point 0, 4, and 0.